Python is a weird language sometimes. Expected encoding here is written like a constant, but there actually isn't anything ensuring it's a constant. I can change it? Yep, I can change it. So how can a constant that isn't guaranteed to be constant be useful? Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to talk about constants and how they can be useful even when they aren't constant. Now, in most programming languages, when you declare a variable as being a constant, that means it can't change. It'll only have one value while the program is running. It'll be constant. This lets the compiler or interpreter make some changes or optimizations, and you can write the rest of your code knowing that constant won't change. But Python doesn't really have that. In Python, generally the convention is to indicate that a variable is a constant by writing the name in uppercase and never changing the value. But as I showed in the intro, that doesn't prevent the value from being changed later. It's just a convention that most people follow, but nothing forces them to follow it. So how does a mutable constant provide value? Well, it can provide value in a couple of different ways. It'll ensure that the various spots in the code that should be referencing the same value are in fact referring to the same value, preventing mismatches. And it can make it easier to know how to change certain arguments in function calls when you want to modify certain behavior. And the nice part is that these reasons will work in languages that enforce constants being constant. These aren't just benefits for language with mutable constants. Now, let's look at some examples to see what these values look like in practice. To start off, we've got a little function here that takes in an input file and uses ffmpeg to apply some filters to it to generate a new file. Looking at the body of the function, we've got two magic values here. We've got 1.0, which is basically a check to see if our speed's close enough to 1. We don't bother adding a filter to change the playback speed because it basically won't be noticeable. And then we've got minus 10.0. I equals minus 10.0 for the filter name loudnorm. So this filter normalizes the loudness of the file, which if I'm new to this code, I may or may not figure out by looking at this. But how does I play into this? Well, I is how we set the loudness target. So instead of just sticking in a minus 10 here, we can create a constant. Let's say loudness target equals minus 10. And then we'll use that instead of the minus 10. And now when I read this code, it's much easier to see that I is probably being used to determine the loudness target for this filter, as that's the name of the constant I'm passing in. And not only is this easier to read, but I think it's easier to change if I need to change it. If later I decide that the loudness target should be minus 9 or minus 11, I can just change it up here in loudness target, and I'll probably feel confident that it's going to do what I want. Otherwise, if we were still back in I equals minus 10, I'd probably spend a lot more time digging into the code to try and even figure out that, oh, okay, it's the I value that I need to change in loudnorm filter. And then I might even need to dig in more, because even though that is the only spot I need to change, I would have to make sure I'm confident that that's the only spot I need to change. So by adding a constant here, it helps make the code more readable and easier to change in the future. Let's jump over to example 2 now. So this is a chunk of code that I had in a script that ran some tests. The tests needed to be run with the standard output set to the UTF-8 encoding. So this code is checking to see, is it set to that encoding? And if it isn't, either changing it to that encoding or aborting because we couldn't. Now, looking at this, if I do a quick count, I see we've got the string UTF-8 1, 2, 3, 4, 5 times, and a reference to UTF-16, which I think is a typo because it says we're reconfiguring it to UTF-16 and then we do UTF-8. So 5 or 6 times that we reference UTF-8. Now, these values don't quite feel like magic values because it's quite clear what they represent. Most people reading this would realize that UTF-8 isn't encoding. So if we used a constant here we're not going to get a clearer understanding of that constant telling us, oh, this is the UTF-8 encoding, it's an encoding. That's not happening. But we've got this value repeated in a lot of spots, and maybe one spot that's a typo or an error. So by using a constant, we can ensure that all of these spots have the same value and are consistent with each other. So I'll just create a expected encoding equals UTF-8, and then we can just use that in all of these spots. We'll change the UTF-16 as well, because that's probably an error. And if we run it again, yep, it works, and it's changing it from CP1252, the Windows encoding. Yeah, so there we go. So now we know that all of the spots are getting the same value and we're consistent. And there's also a nice advantage that if for some reason in the future I want to change this to back to ASCII or UTF-16 or even CP1252, I only have to change this one spot. I don't have to change this check and what I'm encoding to and update all the texts. So it's a lot easier. Now, what if I expand this example a bit and have it cover multiple functions? So we've added a little function here, run process, which is just responsible for running a process and returning the results. Now, for the same reasons as before in main, we need to make sure that run process starts the subprocess with setting the encoding to UTF-8, and it does that by setting encoding to the encoding value, which it has, as always, UTF-8. But I also think it's clear that we probably want this value to be the same thing that we're using in main. I don't think it would make sense to go through all the hassle of setting up the encoding in main and then doing a different encoding here. That would probably be a mistake. So just like in the previous example, if we can use the same constant in both locations, we'll ensure that they stay in sync with each other. And if we wanted to change it in the future, we could, and they would both still work. Now, what I could do is just copy and paste that there. But then this seems a little off to me, because having encoding equals expected encoding doesn't sound quite right. We can get rid of this though. But I think instead of expected, maybe something like desired encoding, because I think that makes it clear that this is the encoding we desire for everything to run in. So we just change it there, and then we change all of our references down here as well. Yeah, I think this seems nicer than before, and they'll stay in sync with each other. And once again, we can change desired encoding to UTF-16, ASCII, CP1252, and it'll work. So it seems much nicer. And there you go. A few examples of how mutable constants can be helpful. They can still aid in readability or keeping different spots in sync. If you've got other examples or use cases I missed, please add them as a comment below. If you enjoyed this video, please consider hitting the like button below and subscribing. If you have any other comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.